started. And we are now recording. Welcome everybody. My name is Dane. I am an OLLI student assistant here. And welcome to the virtual OLLI Brown Bag Lunch presentation. And down here, it'll say, have a question, try raising a virtual hand. There's a toolbar, if you could see on your Zoom screen, a little happy face with an emoji. That's how you do the reactions and stuff. So today is remembering the 1992 Cape Mendocino earthquake with a virtual field trip of the Mendocino Triple Junction. And this is going to be hosted with Lori Dengler, Emeritus Professor of Geology at Cal Poly Humboldt. So welcome, Lori.
Thank you very much. Can you hear me?
I can hear you. Everybody can hear Lori? All righty. And so a couple things before or during the meeting, please mute yourself when you're not speaking. Participants will be muted as they enter, but you can unmute yourself for questions later. And during Lori's presentation, if you have any questions or comments, you can do a little reaction or put something in the chat, but Lori prefers that questions be taken at the end of the presentation. And then this little diagram right here shows you that toolbar I was talking about to do a reaction if you wanted to do one. That's a cool little OLLI graphic. Learning should never end. That's what we believe here at OLLI at Cal Poly. And we're going to do a land acknowledgement. We acknowledge that Cal Poly Humboldt is on the land of the Wiyot peoples, which includes the Wiyot tribes, Bear River Rancheria, and the Blue Lake Rancheria. Arcata is known as Gudini, which means over in the woods or among the redwoods. Wiyot peoples continue to remain in relationship to these lands through ceremony, culture, and stewardship. Knowing the history of this area is important, and we value lifelong learning. And just to let you guys know that we are in a brand new year of OLLI membership. So please, 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 if you haven't done so already, check out our classes and renew your membership if you're already a member, or if you want to participate in our upcoming summer and fall classes, come on in and join. We got plenty of room and we're always looking for more people. And just a sneak peek at some of the classes that we got in summer 2022. One of which is the Back to Camp. That's our camping trip, Back to Camp Lifelong Learning in the Redwoods. That is going from Monday, August 1st to Friday, August 5th. During the first week of August, OLLI will be hosting an opportunity to camp at the Wolf Creek Education Center in a beautiful Redwood Park setting. Register before July 12th for best class and activity options. There's still slots open. So please, if you want, go ahead and visit our website at the Back to Camp section. Camp classes are open to OLLI members only. So please, if you haven't renewed or joined yet, go ahead and do that. It's going to be so much fun. You're going to love it. All right. And then some upcoming classes this week and next week. We have American Heroes, Dolores Huerta and Larry Itliong. That's going to be Thursday, July 21st. And then we got a cool karaoke class, Fear or Adrenaline, singing on the stage. That is going to be Thursday, July 21st, and next week, the 28th. And then we also have Reconnoitering the Redwood Highway on Saturday, July 23rd. And we have a really cool Trinidad Head Lighthouse tour. That's going to be Friday, July 29th. And those are just 4, but there's so many more classes. And please visit us on our website to go check all of those out. And then we got a deadline for register for classes. So soon as possible, sign up for the classes as soon as they're possible, but no later than 3 days before the class start date. Because if we don't have enough people enrolled, the classes don't happen. So just keep that in mind when you're signing up for the classes. And thank you, everybody. Friends of OLLI, our program is not possible and would not be possible without your support. Library is open for OLLI members. If you are enrolled and an OLLI member, you have the same permissions and access to library resources as a Cal Poly Humboldt student. And if you're looking to have a scholarship for any OLLI classes, You are eligible to apply for scholarship funds to help defray the cost of course fees. If you want to apply, you may submit an OLLI scholarship request form. Those can be found on our website. Scholarships may only apply to course fees and not to OLLI memberships. So the membership fee applies, but the course fees are covered by the scholarship. And based on financial need, these are limited 2 per term. And finally, thank you to all the OLLI volunteers. We appreciate all your help. We really, really thank you for your presence and your participation. So without further ado, I'm going to turn it over to Jane, who is going to introduce our speaker for today.
Hi there, everyone, and welcome. And just one kind of amendment. If it's not 3 days from the class and you still want to try to sign up, go ahead. It just means that you take the risk if there weren't enough people who signed up that the class would be canceled. That's why we asked that. And then we have to hustle to get you in. So it doesn't mean you can't sign up. It just puts the class at risk if enough people haven't signed up. So if it's the day before, go ahead and try to sign up. If the class is ongoing, we'll fit you in, I'm quite sure. So anyway, welcome to our first of 2 brown bag lunches this summer. Because of the camp, which I would highly recommend you consider doing. By the way, if you have gotten a program, all the classes that are being given and the dates and times of those classes aren't all in the catalog. So you need to look online to see what's being given when, and when the transportation is available to you at no charge as part of the class fee if you're going for half a day or a full day. So be sure to consult the website if you wish to attend. We still have room for people to join the camp. It's not for another 2 weeks. So it's going to be a wonderful opportunity. This is an experiment we're doing, and we'd love to have you come and join us. And now back to our presenter today. Lori, who is well known in our community, is an Emeritus Professor of Geology at Cal Poly Humboldt. She has expertise in earthquakes, tsunamis, and hazard mitigation. Since retiring from teaching, I don't think she's totally retired because she's teaching here. Lori continues to provide scientific advice to the Redwood Coast Tsunami Work Group, engage in earthquake and tsunami outreach projects with California Office of Emergency Services, and writes the Not My Fault column that appears in the Eureka Times Standard most Sundays. She's delightful. She keeps up with everything, and we're delighted to have her here today. Welcome, Lori. It's all yours. And you will introduce the other 2 people that are speaking.
Thank you very much. It's always wonderful to be here. And today you've got a really special treat because I'm actually the minor presenter. I'd like to introduce Thomas Dunklin, who I probably first met late 80s, early 90s. There's Thomas. Yep. Thomas is really the one who is most responsible for the video we'll be looking at in just a moment, and I'll give you a chance to hear his take on that in just a sec. And then I want to introduce Amanda Admire, who basically does all the hard work. I have ideas and she carries them out. She'll introduce the wonderful website she developed about the 1992 earthquake and this video. But I thought a good place. So first, before I kind of launch into anything, I want to give you a rough outline of what I think, what I'm hoping we're going to do today. Each of the 3 of us will say a few words about how we first met the Mendocino Triple Junction. And then we'll run the 13-minute wonderful video that with much blood, sweat, tears, and enormous talent that Thomas managed to complete a couple of months ago. Then we'll actually have a chance to let you ask some questions after we show the video. Depending on how long that sort of discussion goes, Amanda will then introduce the website, and then I have maybe a 10-minute little PowerPoint on what we've learned since 92 and what the next 30 years might bring. So for starters, let me say a little on how I met the Mendocino Triple Junction. Probably didn't even know its name back in the late 60s when I was an undergrad at Berkeley. And plate tectonics, the idea that the outermost surface of the earth, the kind of large plate rafts are moving around, was first proposed and highly debated. And then by certainly the time my undergrad was over in 1968, it was pretty well accepted. So it went very fast from 64 to 68, from being still a little controversial to being accepted. And these points where multiple plates meet became known as triple junctions. And I was sort of vaguely aware that there was one of these points off the coast or along the coast. At that time, it actually was mapped just off the coast of Northern California. When I got my temporary teaching position at Humboldt in 1978, suddenly I learned it had a name and that it was a whole lot more important. And I continue to learn about the Mendocino Triple Junction with every passing earthquake, every passing year. It becomes more and more interesting. Thomas, let me throw it to you.
Okay. Can you hear me okay? Yep. Okay. So, yeah, my name is Thomas Dunklin. I live down here in Petrolia. My place is literally on the Triple Junction. If you follow the band of earthquakes that comes in from the Pacific on the Mendocino Fault, it basically goes right underneath my house. And so I'm lucky enough to be feeling a couple of earthquakes a week often down here. Lori, to remind you, yeah, we first met in '86 when I came to Humboldt as an undergraduate. And my first general geology class was with Gary Carver, who, like Lori, is obsessed with earthquakes and especially great subduction zone earthquakes. And also Bud Burke was one of my professors at the time. And we took geomorphology and soils with Bud. And we would drive down to the Mendocino Triple Junction to work on these very closely examined soil pits that were up on these 250,000-year-old terraces. So with Bud, we would come and spend 3 days at a time digging holes, and we would often have representatives or other researchers from NASA or the Jet Propulsion Lab or other space and soil scientists who were interested in trying to use soils as a technique for understanding the ages of surfaces, which would help us to interpret some of the landforms around here with regard to how often earthquakes are happening. So yeah, I spent many days and weeks in the late 80s and early 90s down at the mouth of the Atoll with groups of great scientists like Oliver Chadwick and Alan Gillespie and Bud and Gary. And when I graduated from Humboldt in geology in 1991, I managed to land a kind of research assistant position with Dorothy Meritz, who is a great geomorphologist who'd gotten funding from the National Science Foundation and USGS to look at how earthquakes are affecting the landforms in the riverscape, because we have huge river terraces on the lower Atoll, huge marine terraces along the coast. And we wanted to try to understand if those two sets of terraces were related. So we got to spend a lot of time crawling around all the corners of the Atoll and the Bear River and the coastline just when the earthquake started to happen. And we were starting to do a survey of long-term uplift in 1991. And when the earthquake happened in 1992, it was such a synchronicity that the locals actually blamed us for the earthquake, because the thing that we were studying was the thing that just happened. And it had never happened. I don't think in the lower 48. We're probably the first place where we were able to measure uplift directly in anything other than Alaska, is my guess. So I came in here in 91 and immediately felt at home on the Triple Junction. There's something magical about this place. And so after our research season ended in 91, I continued and I started teaching geology at the local high school. And I started working with the Mattole Restoration Council and the Salmon Group, working on fisheries restoration. And that gave me a sort of application for my geologic research and understanding beyond earthquakes and tectonics. So I've been down here on and off ever since, and moved back here full time after being up in Arcata for about 10 years. So that's my short story in geologic time.
Thanks very much, Thomas. Amanda. Amanda was a little newer than either Thomas or I to the Triple Junction, but she is as fully immersed. Take it away on your intro.
So I grew up in Mendocino County, so I was familiar with earthquakes, and I knew that we had more earthquakes here than those in other areas of the country that I knew. But I did not know that it had an official name until I came to Humboldt as a student, and I took an intro geology class and really started learning more in depth about plate tectonics and faulting and all of that, and got an opportunity to see it up close and personal on the field trips in the geology department. And so I am very new to the Triple Junction name, but with my education at the university and then going on to get my master's degree, I then teach at the university now in the geology department. So I have the opportunity to share the wonder that is this amazing geologic setting, and the mysteries that come with it to students that are fresh to the idea and learning all about it for the first time.
Thank you, Amanda. And to give you a feel for what we're talking about and this very, very special place, Amanda's going to now run this 13-minute video and take it away.
All right.
April 25th, 2022 is the 30th year anniversary of the 1992 Cape Mendocino earthquake sequence, when 3 large earthquakes occurred in the vicinity of the Mendocino Triple Junction. The 3 quakes produced over $60 million worth of damage to homes, businesses, roads, and bridges. Fires broke out in the towns of Scotia and Petrolia. Steep slopes failed in the forms of landslides and rockfalls. Liquefaction occurred along river margins, and the coastline near Petrolia was uplifted up to 4 feet in places, killing thousands of intertidal organisms like mussels and gooseneck barnacles. Today, 30 years later, the mussels and barnacles have recovered, and the tide pools look healthy again. Join us now on a virtual tour of the Mendocino Triple Junction to explore the most seismically active region in the state of California, and to learn from some of the lessons from the recent and the geologic past.
Right here is one of my favorite field stops in the whole Cape Mendocino area. We have this beautiful view of the coast, of this flat, and it also shows us something about what is going on here geologically. Back in 1992, after the Cape Mendocino earthquakes, it was immediately noticed that suddenly it looked like we had a low tide all the time. And if you look very carefully, you can actually see outlined in that flat the remains of prior coastlines. This is an area that pops up repeatedly in great earthquakes, most recently in 1992. So we're able to study the rocks here And we're also able to get a better understanding of this entire incredible triple junction area.
The rocks provide some clues to the secrets of the triple junction, but the earthquakes themselves and the science of seismology provided the deepest insights into this region.
My name is Bob McPherson, and I've been studying earthquakes in this area since 1968. I built a seismograph and brought it down here and found a lot of earthquakes here, 3 a day almost, unfelt earthquakes. In 1974, Pacific Gas and Electric was asked by the Atomic Energy Commission to find out about the hazards that affect the power plant. And in order to do this, we built the Humboldt Bay Seismic Network. That was Terra Corporation. So the network was about 16 seismographs, one of which was just north here, down by the triple junction. And the idea was to find out, what the tectonics were of this area. And so in the 60s, this idea of plate tectonics was introduced. The idea is the outer part of the Earth, the lithosphere, strong Earth, moves around on the asthenosphere, weak Earth. And these plates are about 60 to 100 kilometers thick. And they move around and interact. They converge, come together, and make mountains. They move apart and make valleys, diverge, and they also are slide past each other, strike-slip boundaries. So here in this region, they're converging. And so we have a lot of tectonic activity uplifting things.
One of the things uplifting the most around here is the King Range. These mountains are growing at nearly the same rate as the tallest mountains in the Himalayas, making them some of the fastest growing mountains on Earth. Along the coast, as the mountains uplift, they leave behind a flight of marine terraces. And most of this uplift is due to the northward migration of the Mendocino Triple Junction over the past few million years.
The story of the Mendocino Triple Junction begins about 30 million years ago, somewhere in the vicinity of what is now Los Angeles. And that's when a ridge first hit a subduction zone and started the San Andreas Fault.
Today, the San Andreas Fault ends near the mouth of the Mattole River, where it collides with two other huge fault systems. This is what we now know as the Mendocino Triple Junction. On a map, a triple junction looks like a point where three plates meet. But in reality, it is not a point. It is a zone, a three-dimensional zone, a four-dimensional zone if we add the dimension of time. That is the point. It is not a point.
The actual triple junction itself is a diffuse volume of the Earth. If you forced me to say where is the triple junction, I think in 1992, the Friends of the Pleistocene did as good a job as any by putting a placard up at AWA campground and somewhere in between Honeydew and Petrolia along the Mattole, and that's as good as any place.
Now that we have a better sense of where the Mendocino Triple Junction is, let's talk about what it is.
So a triple junction is where those three plates converge. So the Mendocino Triple Junction is the junction between the Pacific Plate, which is to the southwest, the Gorda Plate to the north, and then the North American Plate, which is lying to the east.
Earthquakes in the Pacific Rim tell us exactly where those plate boundaries are. And this animation of earthquakes shows the frequency of earthquakes throughout the entire Pacific Basin. More locally, it shows us the frequency of earthquakes on and around the Triple Junction.
Globally, there are probably at least a dozen triple junctions. Ours is unique in that ours is sort of onshore, and that's pretty rare to have those onshore. Most of the triple junctions are oceanic triple junctions, and they occur out in the middle of the ocean. I sort of like to think of the Mendocino Triple Junction as sort of encompassing the area from at least Punta Gorda here up to Cape Mendocino here, and inboard at least to maybe Petrolia or Honeydew over here. So this whole area is what we would refer to as the Mendocino Triple Junction.
The northward migration of the Mendocino Triple Junction has created some impressive landforms over the past few 100,000 years.
What we see are things like marine terraces that have been uplifted periodically during these large earthquakes. And if you are down in Cape Mendocino, you'll notice that there are areas where there are these flat surfaces that may be on the order of a few meters to hundreds of meters wide. And those surfaces appear to be sort of stranded above sea level. And those are indicating times when you basically had some sudden motion that produced this uplift on the order of meters during any given event. And there are suites of these that sit up, and some are many hundreds of feet above sea level now. Think of the Mendocino Triple Junction as sort of a collision zone or a bumper that's in between all of these. And as you're bringing the Pacific Plate northward, it's colliding with the subduction zone and the Gorda Plate that's not getting out of the way fast enough up here. And so that's why we have such a high standing area in the King Range and such, is that essentially things are not able to move out of the way, so they're moving up. And so we have these really steep drainages, we have these really steep, high relief mountain ranges that are there. And that's all a manifestation of the San Andreas moving into sort of our area.
Today, GPS stations can record plate motions in real time. Changes in direction and length of the arrows reflect the impacts and extent of plate interactions.
Here's the strong influence of the Pacific Plate corner in a northwest direction headed toward the Aleutians, and you can see it diminishes as one goes to the east.
These crustal deformations and uplift events all happen during large earthquakes. What do we know now about the sources of those earthquakes and their relative hazards?
We have 5 hazards here on the North Coast that we need to be concerned about. And these were all written about in a paper Lori Dengler, Gary Carver, and I defined them. The 5 different sources of earthquake hazards are the San Andreas Fault, the Mendocino Fault, intraplate, within the plate, Gorda earthquakes, intraplate North American earthquakes, and then the gorilla in the room is the Cascadia subduction zone.
With all of these different unique sources of earthquakes, it is not surprising that folks who live around the Triple Junction are well adapted to earthquakes. But what about the people who are new to the area?
Families who've lived here for generations understand the need to be self-reliant. Water stored, food stored, they've seen it before, they'll see it again. But over the past several years, we've seen an influx of newer people into this area, drawn by the beautiful setting. They haven't experienced earthquakes or even large floods. We often talk about isolated islands of humanity. These can happen in large winter storms when floodwaters remove bridges and landslides cut off roads, but it also happens in earthquakes. And so it becomes really important to reach this new generation and instill the resilience factor into their lives so that when the next earthquake comes, they and their families will be prepared. We need to understand that one earthquake might not be the whole story, that we have to psychologically be prepared that we could have a number of very strong earthquakes over a period of seconds, of minutes, of hours, or days. And having a better understanding psychologically and in terms of preparing your home and community really can make a difference. Preparing for earthquakes involves certain fundamentals no matter where you are. You need to understand that as soon as the shaking starts, you need to protect yourself and you need to teach your kids to protect themselves. Drop, cover, and hold on so you're not hit by flying objects, And so you are able to fight that urge to run out the door, which is the most hazardous thing you can do while the ground is shaking.
It has been 30 years since the Cape Mendocino earthquake sequence. We now understand that these quakes are responsible for the landscape as we know it, both for its rugged beauty and for its potential hazards. We've had many earthquakes since then, and we will have more, potentially even larger earthquakes in the future. It is now up to us to both be prepared and to live prepared.
Thank you, Thomas, for that incredible piece. Every time I watch it, I learn a little bit more about it. So now might be a good time to either put some questions in the chat box or raise your virtual or real hands. And we'll spend a little bit of time talking about the video if there are things that you're not clear about. Anyone want to start out?
Yeah, I have a question.
Go ahead.
I was here in the 80s and I experienced the earthquake that happened, but I can't remember the year, the big one.
Yeah, the one in 1980 that was just offshore of Trinidad, the one that knocked down the Tompkins Hill overpass. Is that the one you're thinking about?
I thought it was in 82, but I think you're right. It was.
Yeah, it was 1980. Okay. And that was my first Humboldt County earthquake as well. We lost an antique clock in it.
Yeah, I was asleep, and when the 1989 earthquake happened in Santa Cruz, I was there too. So I knew exactly how big it was.
The Loma Prieta was actually a little smaller than that earthquake we had in 1980 and also smaller than our 92 earthquake, but it all depends on how close you are. That earthquake in 1980 was actually not within the Triple Junction region, but I would certainly argue that it is a direct result of the Triple Junction, that the movement that has created this buttress of the Mendocino Fault that causes squeezing in our offshore area. So not Triple Junction, but certainly related.
Thank you. I had one other thing. The direction of the shaking. Could you talk about that a little bit in terms of the Triple Junction? Like, what do you feel? Do you feel that up and down or side to side?
Well, that's actually a really good question. And I'll kind of get back to it at the end, because it turns out the Triple Junction gives us every type of earthquake and every type of earthquake emotion that you can imagine. So sometimes the strongest motion will feel sort of east to west. Sometimes the strongest motion will feel north-south. And anywhere in between. That depends really on the orientation of the fault. And one of the things in the last 30 years we've really learned to do is become very good at determining exactly how a fault is moving.
One of the things I'm curious, that is a wonderful video. Thank you so much. I would love to see you continue adding on to that video. and bringing us up to date. When was that video completed? It goes through when?
Well, it was completed just before the 30 years, so marker. So in April, early April of this year.
Oh, of this year. So it is pretty much up to date. And how much of an uplift have we seen, like in our lifetimes, in that area?
Thomas, you
Yeah.
want to talk a little bit about the uplift episodes? In our lifetime, we
Yeah.
see what happened in 92.
Yeah, exactly. We really have only seen uplift this one time. You know, the earthquake in 1964 in Alaska produced a huge amount of uplift, and Gary Carver was up there measuring that, and he noticed the similarities between Humboldt County and Alaska. And so we've been expecting a quake like this for quite a while, but never really had the opportunity to witness one. So when it did happen, it was really, I just remember being ecstatic and excited. Some people were sort of terrified and afraid, but earthquakes tend to make us rather happy.
Well,
We
So
have
I've-
something to study.
we're really fortunate that we had no deaths. We had about 400 injuries, but none were life-threatening in 92. We have more earthquakes than any part of the lower 48, yet we've only had 2 earthquakes since 1850 that have actually caused a death, 1 death each, in 1932 and in 1954. So we're very fortunate in our wood frame structures and our relative sparsity of population centers, but that doesn't mean we can ignore it.
Just out of curiosity, when we're building buildings over 3 or 4 stories here, what has to be done to safeguard them, and can we use concrete? And what kind of foundation do we have to have in order to create that stabilization, that because they aren't generally wood when they go over 4
Well,
stories?
actually, a lot of our 3-4 story buildings are still wood, but fortunately, California has some of the best building codes for earthquakes anywhere. And for new construction, or basically any construction since the 1980s, our taller buildings, of which we have very few, are going to be built according to a strong code. What is actually more frightening are the buildings that were built in the 50s and 60s that were built to codes that are not nearly as strong as they are now. And certainly we've seen in other earthquakes, most notably a 6.1 that occurred in New Zealand in 2011. 2 of those buildings, types of buildings, 1960s reinforced concrete buildings, collapsed. So a lot of attention now in California is turning towards what can be done, not to retrofit. I mean, we know that unreinforced brick buildings are a problem, but this whole class of older concrete structures. I think this is a good point for Amanda to kind of introduce the website where you can go and view this video, share it at any time, and some other info. Will take maybe 10 minutes to walk through that, and then I'll come back and sort of give you a taste of what we've learned seismologically in the last 30 years.
So in the chat window, I actually provided the link to the webpage so that everyone has access to it. But I will go ahead and share my screen and walk you through this. This page was created on the Redwood Coast Tsunami Work Group website as a place for us not only to host and really show this video and give it its necessary place to keep this available to all those that would like to view it, but also to provide some of that context, like what Lori and Thomas were sharing about the events themselves and the earthquakes that took place in 1992. So this webpage has a lot of information on it, and we invite you all to explore and follow the links and watch the other videos at the end of it, and also read the articles to learn more about these. You'll notice in the right-hand margin, Lori did write a series of articles earlier this year that highlighted this event, this sequence of events, and those are all embedded here for you to review. And as you work your way through this page, you'll see there are certain sections that we've highlighted. The first being the earthquakes themselves and what actually took place. There's also an overview of the geologic setting that we have, which was described really well in the video. But for those of you that wanted to look at that in more detail, that's provided here, as well as the impact of those 1992 earthquakes and really what happened in some of the communities here on the North Coast. And then we have two sections that explore what we've learned in the last 30 years and what actually came out of these significant events on the North Coast and how it has helped us advance our earthquake and tsunami hazard preparedness. And so there are some opportunities to hear from the experts in that section. So these two images should be familiar to you. They were in the video as well, identifying the location of those three significant earthquakes that took place in 1992, as well as what we call a seismogram of the events. So the instrumentation that records the ground shaking provides us a visual of what it looked like. And so there were some great graphics in the video highlighting this seismogram. And so we have this here in full display for you to view. Not only did we have those three large events, but there were also several smaller events in there. As you continue down the page, you'll get a chance to look at those intensity shaking maps. And so this highlights what one of you asked was how it felt when those earthquakes occurred. And each earthquake has its own feel to the people in that area, depending on, as Lori mentioned, your location to the epicenter and what is going on during that earthquake in particular. So here what you'll see is the shaking intensity. And it's color coded with a scale from weak to violent on this scale here. And the color coding is related to the warm. So the warmer the color, the more intense that shaking. So you'll see here a description of those shaking intensities for those earthquakes. And in the bottom portion right here, it really detailed in on all three of those larger events that occurred. Now, these are early diagrams of those, and the USGS actually produces maps of these in pretty near real time for events that are taking place, and they inputted that information and produced maps that might be a little more familiar, you might be a little more familiar with, that sometimes get published in news and social media, showing the shaking distribution for the North Coast. And as you can see here, a lot of the North Coast felt these 1992 events. In addition to the ground shaking, these events produced a tsunami. And the tsunami was recorded in Crescent City as well as in Humboldt Bay. And we can observe those on graphs called merograms, which are records of water level. And that's what you're seeing here is the merogram for Crescent City and the merogram for Humboldt Bay, which the location is called the North Spit. And so merograms show the record of water level, which include the tide. So we have that constant up and down motion. And the tsunami is this higher frequency jitter that you're seeing on this water level here. That's the tsunami riding on top of the tide in Crescent City. And then you see another signal similar, but it looks a little bit different, that was recorded here in Humboldt Bay. So these did produce tsunamis in this area. There's a map that was included in the video as well, but this is that tectonic map, that larger scale map showing you the tectonics in the area for the triple junction. And again, it's noted as a point, but it's not a point. It's this whole region out here. And you can see the dynamic between the North American plate, the Pacific plate, and then this portion that is forming the Cascadia subduction zone, which is a portion of the plate that is diving underneath the North American plate. Now, the impacts are what many of us remember or look at when we're trying to identify what could happen. And so our section on the impacts includes information on what happened in certain communities, as well as the full video that was collected by someone who was in Ferndale during the time of the earthquake. And there was a clip in the video that we showed at the beginning of this that showed people in the streets. And so you can actually see that full video here if you wanted to see what it was like during portion of that earthquake, and then as people were recovering from that. There was a parade taking place in Ferndale at the time, and so there was people there. There were people there that were actually capturing footage of it, and so there's some very interesting video footage, firsthand experience to see there. Now, 5 of our communities were pretty heavily impacted, and you can see here we have Ferndale, Petrolia, Rio Dell, Scotia, and Fortuna all experienced shaking damage from this sequence of earthquakes in excess of, I believe it was $61 million of impact to the area. And as Lori noted, we had no deaths, which was wonderful because that means that we're doing something right in our preparedness. But we did have injuries, and it's always important for us to remember those steps for safety during earthquakes. And at the end here, this is our retrospective section on looking at what has been done in the last 30 years. In terms of earthquake hazards, there have been several advances, as well as legislation that has been created to help us be safer during these events. And there's a video here with Dr. Peggy Helwig, who talks about the earthquake early warning system and what that means and how that is implemented here in California. And we have our tsunami hazard preparedness section, which also highlights the advances that we've made in terms of tsunami preparedness and awareness, including the creation of national programs that have been developed. And there is a video here with Lori who talks about the impacts of the 1992 earthquakes and how it has taught us a lot about tsunamis and tsunami hazards. So that is our webpage. There is a lot of information, but we welcome you all to explore it and take a look.
Thank you, Amanda. So to kind of finish up and hopefully give us a little more time for questions, I'm going to, if I can manage sharing my screen, talk a little bit more about what we've learned in the last 30 years. In terms of the triple junction and our general earthquake hazard. So the video talks about a paper that Bob McPherson, Gary Carver, and I published in May of 1992. We were actually reviewing the final galleys of it when the 92 quakes happened, and we had to quickly add a little bit more. So this particular paper is accessible online. We'll include a link to it on that 92 remembrance page, and you're welcome to take a look. It's a good place to begin to compare where we were in 1992 to where we are today. So on the left is the epicenter map that we published in that paper that shows the large earthquakes that we had in our historic record. And not surprising, there are quite a few of them. On the right shows those same earthquakes with a modern view. They're better located, and now instead of just color coded by size, they look a little bit like beach balls. And this is from Berkeley's Moment Tensor catalog that actually shows the orientation of the faults. So now not only do we know where the earthquakes are, we know very precisely the type of faulting. these are just way cool images that Anthony Lomax did some very detailed locations. And on the left, you can see epicenters since 1984, the larger earthquakes in red. And the colors, other than the red, shows the depth. So we now have a much better detail of the sort of three-dimensional view. And the great animation that Anthony put together on the right shows how we have these complex structures, especially in the vicinity of the triple junction. This is a more detailed picture just of the triple junction area, showing these moment tensors, fault plane solutions. And I've included a very simple key over on the left that shows how the pattern, if you see basically four colors, 2 areas of dark, 2 areas of light, that's what we call strike slip. The motion is horizontal, like cars on a freeway. If you see an area of light colored in the middle, dark on the outside, that's a normal fault. That's where stretching is happening, where things are being pulled in 2 directions away from the middle. The inverse of that, where it's dark in the middle, is where things are being squeezed. And then, of course, we have combinations, what we'd call oblique, that can be partly, the fault is partly squeezing, partly moving horizontally. And if you look at this detailed map that Peggy Hellweg put together of North Coast earthquakes, about magnitude 4.5 and larger since 1984, you can see we have every type of beach ball you can imagine. They're going crazy. Some of them along the Mendocino Fault are pretty much strike slip east-west. But then we have, especially in the vicinity of the triple junction, a whole variety. A good example is an earthquake that I expect most of you may have experienced. Just back in December 2021, actually December 20th, I obviously didn't prove my title clear enough. We had what at first seemed to be a single earthquake, 6.2 earthquake that was shown to be somewhat offshore, the initial epicenter maps. But a couple of weeks later, when seismologists dug in much more deeply, it turned out there were actually 2 earthquakes and a whole bunch of others. The sequence began with a 5.7 earthquake on the Mendocino Fault, sort of in the vicinity of the triple junction. All of this stuff here is in the vicinity of the triple junction. That earthquake at 12, 10, and 20 seconds. Usually I don't bother to talk about seconds with earthquakes, but with this one, the seconds are important. And that was followed 11 seconds later by a 6.2 earthquake onshore. These earthquakes were very different, but clearly related. The 5.7 earthquake was an east-west strike slip, only 10 miles deep. The 11-second later earthquake was almost twice as deep and on a northwest-southeast trending strike slip fault. After those earthquakes, we've had aftershocks. That sequence pretty much over now, but we had aftershocks both in the vicinity of the Mendocino Fault and a number of aftershocks onshore. So like 1992, we see this sequence of earthquakes in one part of the system and another part of the system, clearly all related in this jigsaw puzzle connection of the triple junction. So what we thought back in 1992, and Bob McPherson talks about it in that video, is we defined kind of 5 main areas of earthquake sources. What I certainly feel now is we've got to really add the Mendocino triple junction because it is so complex. We have so many different kinds of earthquakes. The earthquakes can be deep, they can be shallow, they can be compressional, they can be extensional, they can be strike slip, and they're really frequent. So I want to end with what the next 30 years might bring us and introduce a very exciting experiment that is just about to end. We call it the Humboldt County DOS, Distributed Acoustic Sensing Optic Fiber Experiment. And for the next couple of days before the instrument is pulled, we're using the optic fiber that currently runs from Arcata to Eureka as a seismometer. And in addition to the optic fiber, we have a whole number of little geophones, the yellow pins, and we have 4 high precision broadband seismographs. And from this information, we hope to really pin down how to use optic fiber, which is going in everywhere, to basically extend our seismic networks, both onshore and offshore. And with that, I want to thank, obviously, Amanda and Thomas, but also Peggy Helwig, Bob McPherson, Doug Drager, Anthony Lomax, Jeff McGuire, Connie Stewart, the wonderful person at Humboldt who's pretty much facilitated this DOS experiment, and lots of other folks. Thomas, anything you want to add?
No, I think.
Share, go ahead.
No, I guess one of the things that I regret not getting into the video was the habit that I have gotten into whenever I feel an earthquake. And it played out so well when this last earthquake happened by Lori is as soon as an earthquake starts, I start counting 1, 1,000, 2, 1,000, 3, 1,000. And at 15 seconds on this last quake, a giant, S wave came in, but it wasn't an S wave, it was another earthquake. And by doing that count, it's kind of like gauging how far lightning is away from you. You see the flash and then you hear the thunder. With the earthquake, you feel the P wave and then you feel the S wave. And if you have a sense of what's the spacing between those, you know right away whether that's a substantial earthquake that you have to be worried about tsunamis or whether it was just another regular, background quake here. Because I think everybody has the same experience that it feels like the earthquake went on forever, but it didn't. It went for 10 seconds. Or it went for 20 seconds, or it went from 2 seconds. So anyways, if you are in earthquake country and you feel an earthquake, if you can keep your wits about you, just start counting and it sort of calms you down. And then when that earthquake is over, you have a sense of what you just experienced. And I can basically estimate an earthquake down to about 2 decimal points. And I often text Lori right away, 5.3, pretty close, 5.1. I'm right on top of it, so
you are
anyways,
right on top of it. You're literally on top of it.
Yeah, but it's a zone. Remember, a 4-dimensional zone.
Yeah. Amanda, do you have anything you want to add?
Aside from just inviting you all to visit the Redwood Coast Tsunami Work Group website to see this video in more detail if you wish, or to read more about the information regarding the earthquakes and the impacts, we greatly appreciate your visits to the site, but also any information or stories you would like to share.
So if we have, we've are about the end of our allotted time, but if anyone has some questions,
Oh, we actually have until 1:30 if you wish to
Oh, okay. Well,
survive
if
that long.
if
We have
people
lots of time
want-
if you want to take questions.
If people want to ask questions, now's a good time.
I just saw one question asking, what does the P wave and the S wave feel like? Well, the P wave is the first thing you feel, and it can be pretty much of a jolt. And the S wave is the second thing you feel that often is a little bit more rolling. And then the surface waves come in after that, which can be rolling or side to side or up and down. That's the kind of chaos. But just P and S is push or primus and secundus, but it's kind of like push wave and shear wave. So when you feel that separation, you'll know it.
In 2000, late 2000s, after we'd moved here, I happened to be out at Freshwater Valley Stables, and the car was parked east-west, and I was in the Redwood barn, and all of a sudden it started shaking. And literally everything was rattling. And of course I ran out of the barn. And I saw my car going back and forth. And I think that was I don't know whether it was a 5.8 or 6.2. But that alerted me to my first earthquake. And I don't know, you didn't describe that or where exactly that one was. And I think since a number of people probably did experience that, it would be interesting to include that one in future presentations because a lot of us did feel that.
When did that earthquake happen?
Sometime in the late 2000s, like 2009, 10.
Well, there's the 2010, the January. That was our last really big damaging.
That
earthquake.
was probably the one.
Okay, Saturday around 4 p.m.
Yeah, that sounds about right.
Yeah.
It was incredible because it was rolling.
Yeah, again,
There was an initial shaking,
yeah,
and then rolling, and I thought it was like about 10 or 12 seconds. I don't know.
That was a not a triple junction earthquake. Again, very similar to the earthquake that happened in 1980 in the Gorda Plate. They're the most common ones that we tend to feel in the Humboldt Bay region. But this discussion actually brings up the sort of P and the S wave, brings up something that's very important for people to be aware of. We now have an earthquake early warning system. It's still really in development. And in Humboldt County, we've had more triggers of the earthquake early warning system than anywhere else in the state since it was first unveiled back in 2019. So let me talk just briefly about the earthquake early warning system so that you're aware a little bit of how it works. It's also, we've got a great section on our website that talks a little bit more about it. It's not earthquake prediction. We're not predicting an earthquake before it happens, but that P wave, which is first, it's the primary wave, it's the fastest wave. It's usually, well, almost always weaker because there's just not as much energy in that push-pull part of the signal as there is in the shear wave part of the signal. Because it's faster, if we have enough instruments close to all the potential epicenters, we can locate that earthquake, make a very quick, I mean, I'm talking about 2 seconds of time, determine how big that earthquake is, and then disseminate that information to areas that are further away before that much stronger S wave arrives. I had that experience on December 20th. I was home and I have the MyShake app on my phone. And you have to enable, it's free. If you have an Android, it actually now comes automatically with an Android phone. If you have an iPhone, you have to actually download for free the MyShake app. And I was cooking and suddenly my phone, the voice on my phone says, earthquake, earthquake, drop cover and hold on. And it's like, oh, so I kind of braced myself, dropped down a bit. I have bad knees, so I didn't drop all the way down. And about 5 seconds later, the ground started to shake. It was so great. It was just great having that mental preparedness for an earthquake. Now, as I said, we've had 4 triggering events, and the first one about a year ago, I was just outside of the automatic polygon, so I felt the earthquake and didn't get a warning. Other people did. Then there was one was an aftershock of the December 20th. I was in a restaurant in Eureka, and my phone said earthquake, drop cover and hold on. And I looked at it and I thought, I'm not going to yell earthquake coming. I'm going to wait a little bit and see. If I start to feel that P wave, then I'll say something. It was a good thing I didn't say anything, because in that case, the estimate of the magnitude was way off, and it turned out very few people felt the earthquake. So it's a work in progress, but it's very exciting. And we're really hoping that when the offshore optic fibers are in place and we can use them as seismographs, that our system will get better. So it really is interesting seeing how this earthquake early warning development, every month more seismographs get put in, the system gets better. And I'm hoping that in a few more years we'll be just like Japan, where these warnings are routine and highly accurate.
Chaos Garda asked about the question in the chat regarding how safe it is today and what arrangements have been made for the plant, our nuclear power plant, and all the storage caskets there.
Well, I actually hope all of you will join a brown bag this fall, when I hope if you invite me back, we'll be talking about the history, the geologic saga of the Humboldt Bay nuclear power plant. Right now, I would feel safer on the site of the power plant than almost anywhere else in Humboldt County. It's because all of the waste is now buried in these deep casks below the surface. But I'm not going to get into it anymore right now, because that would be taking away my thunder for the fall.
Okay, just pick a date, Lori, and tell me. But the other question, another question I have is, how safe is it in this area to build buildings over 4 stories? And what would we have to do to make those buildings safe?
My hunch is that you are asking this question because of the proposed gateway project in our
What gives you that idea?
But let me say, first of all, there's no inherent problems with building 80-story buildings in earthquake zones. They're done all the time, all over the world. Earthquake engineering can do it if you put in the money to really understand what you're doing. So the engineering issue is not the question. The question is a whole bunch of other things. So, for example, when you're dealing with any development, you need to be aware of all the potential hazards: tsunami zone, sea level rise, distribution of resources, and so forth. So the engineering problem of designing tall buildings, I wouldn't want to live in one, but I certainly go to them frequently. That's not a problem. I certainly would feel uncomfortable in a building where I might want to evacuate, and I'm in a 15-story building, and to evacuate it, I've got to go down the stairs. But that's not that's not the issue. The much more important issues are one of community planning and all of the potential hazards that you're looking at over a 50-year time window, which is the sort of typical lifespan of construction, which seems kind of short to me. And when you start thinking about a 50-year window and sea level rise, and that we could have, I mean, what we know certainly with these big earthquakes, we know that the bay will change. It will probably get bigger. Now, that might not happen in the next 50 years, but it's most of the models or the studies give it a sort of 16 to 25% chance of happening in the next 50 years, which means it's more likely it won't happen. But boy, if you had those odds in Las Vegas, you'd be doing really well. So it's a complex issue that I hope everyone in the community is engaged with.
Are we likely to have uplift in the Arcata area?
The evidence is that we have subsidence. We see that very clearly in the Mad River Slough, the sort of layers. We've had 5 drop down subsidence events in the last 3,000 or so years that are very well documented. There may even be more. I'm thinking of kind of earlier work, but at least 5 in the Arcata Bay region, where the bay drops down 1 to 2.5 feet. Now, that can be quite significant when you're talking about construction near the bay.
Because right now, Arcata, most of Arcata where it's built on and or will be built on is not in the tsunami zone.
Correct.
And the ponds aren't at risk right now.
Actually, the ponds are problematic. The ponds, the sewage treatment ponds are at tsunami risk.
Oh, but if we have additional subsidence, we'd have a real problem with
additional subsidence or sea level rise, both will basically make our sewage treatment system not functional.
Do we have any estimate of time frames when some of
This
this
is
likely to
getting
happen?
way off. I'd rather keep our discussion more to what we've been talking about. If somebody else has questions about the video, the triple junction.
Lori, I have sort of a practical, personal question about earthquakes in general. I'm living in a wood frame house. It was built to mid-1970 standards, and it's on a concrete slab in Fieldbrook. What do you think about the advisability of going into debt and getting earthquake insurance?
California earthquake insurance is not a great deal.
That's what I thought.
It's become ridiculous. I mean, I'll give you my personal experience. I got earthquake insurance for well over a decade, and about 6-8 years ago, we canceled our earthquake insurance. I think if you can afford it, the most important earthquake insurance is getting a decent foundation. I mean, our son recently bought an 1893 house in Arcata, wonderful house. Very first thing we did was replace the pier and post foundation with a perimeter foundation. To me, that's a much better thing to do than to put your money into earthquake insurance.
We lived in a rental in Arcata, and it was pier and post, and it was the rear end of the house was a good 10 to 12 feet off the ground. And in that 1980-ish quake, it felt like somebody took that house and was doing this with it. And the shaking was so bad that it literally threw water out of our toilet.
Oh, yeah.
I don't ever want to be in that situation again.
Well, I think was it Thomas had the story of maybe this was an exaggeration from 92 about how one earthquake threw the house off the foundation and another one threw it back on, something like that.
Yeah, one quake shifted this little cabin away from a brand new set of concrete steps this guy had built. And in the morning when he woke up again after the third earthquake, the house had jiggled its way back to the concrete steps. So
What more can you ask for? Does
Lori,
anybody
do you
else have
want-
questions?
Do you want stories? I heard you
We
ask
always
for
like
stories.
stories.
Well, I was a senior in high school in 1954 when we had that big quake. And I think that's when we lost the courthouse and Eureka lost their junior high school or the senior high school.
Yep, yep.
And they had to build new schools. But I was working for a woman who was sick with the flu, and she and her young son were both in bed when I was cooking soup. It happened right at noon. And the soup went off the stove and spilled all over the floor and all the dishes came out. And I made my way down the hallway to where they were in the bedroom. I looked out the window and we were by the dairy in the lower Arcata Bottoms. And there were waves, I swear, the ground was rolling 20 feet waves across the pasture where the cows were all running and they were all out of shape. They looked like camels. They were, going like this as they went through the waves. And that's, I've been through a number of the quakes here, but that was the most memorable one for me. So it was a
Well,
good one.
1954 is actually one of the most interesting earthquakes in the record. It was 6.5 or
Yes.
thereabouts. And it occurred, I think it was December. It may have been
Just
a Saturday.
before Christmas, just before
Yeah,
Christmas.
it was on a Saturday, and
Mhm.
there were a lot of people fishing in the Mad River.
Ah,
And they described that the river flowed backwards.
backwards. I've heard that.
And that's something that we see not at all uncommonly in big earthquakes. The most famous example is the New Madrid earthquake in 1811, where the Mississippi River flowed backward for tens of minutes at least. And then when it reversed, it was
Yeah.
like a huge flood. It jumped the banks and it created what we call Earthquake Lake, Lake Reelfoot. Is that in Tennessee? Any rate, I can't remember exactly where it is, but it illustrates another issue that when you feel a significant earthquake, obviously, if you're near the beach in a low-lying area, we hope everybody now is aware of the potential tsunami hazard, that the shaking is your warning to get out of the tsunami zone. But there's also a hazard along rivers. And you can get, like what happened in 54, what happened in New Madrid, you can get this reversal of flow. You can also get landslides. In our area, landslides are really common. A landslide can temporarily dam a river and then break through it, creating an enormous flood. So just as important to get off the beach when you feel earthquake that lasts a long time, it's important to, stop fishing to get out of the floodplain, because you really don't know what could be happening upstream of you.
Are there any other questions? Yes, no? Hello?
There was, is it Yanina and Carl? Did you have your hand up with a question? Or did it get answered?
Thank you.
Always-
I was curious about the fiber optic project. Is there something inherently sensitive about fiber optics that picks this up? Or do you send signals to one of the fibers? Or how does that work?
Well, this whole fiber optic technology is brand new, and there's at least 2 different techniques that I am aware of. The experiment that is currently running along Old Arcata Road involves what's called an interrogator that sends laser beams along one of the strands. I mean, your optic fiber is this bundle of like 26 beautifully prepared glass strands that signals, all of our broadband signals will in the future go zipping along at the speed of light, but no fiber is perfect. There's always some imperfections. And what the interrogator does is it sends a laser and the little imperfections are reflected back. Now, if that fiber is staying perfectly still and nothing is deforming it, the amount of time to reflect off of the imperfection is always exactly the same. But if the cable is stretched or compressed, it will change the amount of time it takes for that reflection. And it turns out everything will deform. I mean, the daily tides will deform the cable. Cars driving on the road deform the cable. But earthquake waves, those P waves, those S waves, those surface waves also deform the cable. And it turns out because there are imperfections along the whole line of the cable, you can actually take this, 10-mile stretch of cable and turn it into 50 individual seismographs by looking at the reflection time from different portions. So it's like having this incredible array of seismic sensors. What we know right now from the system is that we definitely can record earthquakes. We can record earthquakes as small as magnitude 2. We can record the magnitude 7 from Peru that occurred earlier this year. But over the whole purpose of this experiment is to really nail exactly what we're seeing on the optic fiber, because we have all this conventional recording going right next to it. And it could be one of the biggest breakthroughs in enabling the advancement of optic fiber technology worldwide. I mean, we've got some of the foremost world experts working on this. I've had to learn all sorts of new acronyms, and I'm definitely the dummy of the group when it comes to the technology, but it's very exciting. Because one of the big problems we have on the North Coast is we don't have as many seismographs as we would like, and most of our earthquakes are offshore, and we have no way right now of recording those offshore earthquakes in the offshore environment. Now we've got these 2 trans-Pacific cables that are currently being laid, one to Singapore, one to Taiwan. There may be another one soon. If we can, get access to one of these strands, it may suddenly provide us with a totally new view of our offshore environment. It won't be quite the James Webb telescope, but it'll be close to that for Humboldt County.
Thank you.
Question, who is actually doing the study, and are results going to be published sometime in the near
The
future?
study is run by the USGS, and all of the data will eventually be totally public. But for the first 6 months or so, the USGS is going to be, the data is, it's terabytes of data per day. It's huge amounts. They're like 1,000 laser pulses per second that are, it's just an enormous, and so it will probably be months before the data is sort of released. Right now, we're in the discussion with our group, which includes about 8 different universities and the USGS. You know, what are the sort of priority research projects that are going to be done at the beginning? I don't expect to be able to like release way cool images for probably another 6 months.
Yeah.
But that could be another brown bag in the spring, maybe.
Well, we can just have one every semester. No problem.
Right.
Any other questions? Yes, Jenny, do you have a question?
Yes, I have a comment and a question, actually. Thank you, Laurie. I have been attending lorry programs forever and ever and ever because I lived in Manila, so I've gone to a number of those. And so that's a very long time. I've been here since 2000. And over that time, I've come from being absolutely terrified at all moments when anything shakes anywhere, all the way to now. And I just wanted to comment about this program that it is really interesting to see the development of what's gone on in the understandings of all of us. And I feel much safer as a result of watching this today, despite the fact that we're not talking about drop, hold, and cover. We are, but we're talking about a whole lot of other things and the likelihood that one will survive, which is such a different overall picture. So that's by way of thanking you once more, Laurie, but and being really surprised at how the integration has come to be. That's one, this is a little story in relation to the phone app, which I have on my phone, but I guess had not enabled. But I was with somebody at the Arcata Marsh. We had been walking in the Arcata Marsh and were just coming back to our vehicle. So we were in the parking lot, and there's a woman in a car right next to my friend's car, and her alert went off. My friend and I had not noticed anything. Meanwhile, we look at this poor woman in her car, and her car is bouncing back and forth. So, I mean, case in point of exactly what you were talking about. It's like, oh, now I get what was happening. I just thought, oh, as usual, my technology doesn't work or something or other. It's like, oh, that was the point. So thank you for the clarification. Thank you.
Thank you, Jenny. And I want you to know that I didn't pay her to say those things. You couldn't have done a better job of really emphasizing that knowledge is the best way to deal with fear, to really deal with that. The more you talk about it, and this really becomes important for families. I mean, people said, oh, I'm not going to talk about earthquakes because it will terrify my children. Well, what do you think is going to terrify their children? It's like, there's something so scary my parents don't want to talk about it. It's talking is absolutely the first step to doing anything. And, you know, when we first started doing these tsunami hazard maps, a lot of people said, oh, I'm so scared of tsunamis. I don't want to see the map. I know I'm in the zone. And it turns out almost nobody was in the tsunami zone. And evacuating when you're not in the zone is actually not a good idea. We've had people driving to Neeland at 90 miles an hour, not a good idea. So yeah, I think with anything, whether it's COVID, whether it's, I mean, we know a lot less about COVID than we actually know about earthquakes now. But this process of learning about earthquakes has helped me sort of understand that you don't learn everything immediately, and that our assessment changes as more information becomes available. And you really do need to keep looking at the best information that's available.
Any other questions? Speak now or forever hold your peace, right?
Well,
Okay.
thanks to everybody, and a special big, huge thanks to Thomas. The biggest thanks to Thomas, and then a pretty big thanks to Amanda, and thanks to all of you.
Thank
Yeah.
you ever so much. It was great.
Yeah, thanks for showing up, everybody. And yeah, don't panic. Don't panic.
No, I think they feel kind of cool when they happen, but that's all right. That's just me.
Been there, done that.
Well, thank you so much, Lori, Thomas, and Amanda. That was awesome. I literally just installed the my Shake on my phone just now. So
Good deal.
because I live in the marshes, so I am the first to get hit. If
Good.
anything.
Well, just make sure you enable the location services, because
Yes.
it won't work if it doesn't know where you are. Because the whole system works on only notifying people in the area where you're likely to feel significant shaking.
Well, thank you again. We'll look forward to seeing Lori again in the fall as soon as she tells me what the date is.
Bye.
Just send me an
All right.
email, right?
Bye.
All right. Bye-bye. I'm gonna sign
Take
off.
care.
Take
Thank
care,
you.
Don't forget
everybody.
to
Bye-bye.
sign up for courses. They're happening right now.